finding the third derivative of this function. So finding the third derivative means we have to go through single prime, double prime, and triple prime. Let's do the first prime. So the first prime, first derivative. So this one using the simple power rule, you bring the power down and then take the power minus 1. So you bring the phi down and then take phi minus 1. So let's just write that step out. And then bring the 4 down, so 2 times 4, and then raise to the 4 minus 1. Bring the 3 down, and then x raised to the 3 minus 1. And then bring the 2 down, so 2 minus 1 is 1. And then the derivative of 7x is equals to 7. The derivative of negative 60 is equals to 0 because negative 60, this is a constant value, which is a one horizontal line. The slope of a horizontal line is 0. So you can either write nothing or you write a 0. So let's clean up the coefficient. F prime of x that is equals to phi x to the fourth and then plus 8 x to the third and then minus 18 x to the second and then plus 2x and then plus 7. So this is the first derivative. And then based on the first derivative, we can move on to the second derivative. Let's use another color for the second derivative. So f double prime. So this time we bring the 4 down. So we have 5 times 4 raised to the 4 minus 1. Bring the 3 down. 8 times 3 raised to the 3 minus 1. Bring the 2 down. And then 2 minus 1, and then the derivative of 2x. 2x is a linear function. The derivative of 2x is equals to 2, and then the derivative of 7, the constant value, is equals to 0. Clean up the coefficient, so f double prime of x, that is equals to 20, and then x raised to the third, and then plus 18, 24. Why do I say 18? 24. Second, and then minus 36, and then x to the first, and then plus 2. So this is the second derivative. And then moving on to the third derivative, so triple prime. So we have f triple prime, so prime, prime, prime. So we bring the 3 down, so 20 times 3, x raised to the 3 minus 1, and then plus 24 times 2, x raised to the 2 minus 1, and then the derivative of 36x is 36, the derivative of 2 is equals to 0. And then now you clean up the coefficient, so the first one is 60, x to the second power, and then plus 48, x to the first power, and then minus 36. So this is the third derivative. Can we go one more step? Can we go to the fourth derivative? The answer is absolutely yes. So for the fourth derivative, so you are not going to write 4 prime, so just write a 4 in parentheses. That tells me you are doing the fourth derivative. So you bring the 2 down, 60 times 2 is equals to 120, and then x, and then this one, the derivative of 48x is equals to 48. So this is the fourth derivative. Can we do the fifth derivative? Absolutely yes. So let's move on to the fifth derivative. So the phi. So this one, the derivative of 120x is equals to 120. The derivative of 48 is equals to 0. So when you reach to the fifth derivative, you don't have any more x. Do you see that at the very beginning you have x raised to the fifth power? So after you take phi derivative, you bring the power down 5 times, because every time you bring a power down, you have to subtract 1. So after you do this 5 times, the phi will be gone. All right. And then how about the sixth derivative? So the very last one, the sixth. The sixth derivative, do we still have any more value? The answer is no. So the derivative of 120 is equals to 0. So the sixth derivative, let's make that look like a 6. So 6 in a parenthesis, that is just equals to 0. All right, so that is the end of this video. This is a simpler problem, so allow me to introduce a more complicated and longer problem in the next video. All right, I will see you there.